Hello everyone, welcome to another video on the Medidata Perspective channel. In our today's video, we'll be looking at another data set where we'll be analyzing sleep, health and lifestyle. In this data set, we'll be going into a deep dive into data analysis. We'll be looking at exploratory data analysis, how to make use of alternate and null hypotheses to answer data analytical questions, and also creating models to predict a variable. I'll be dividing this project into two parts because it's going to be very long. Okay, so in this first session we'll be looking at data analysis, while in the second video we'll be looking at machine learning aspect of it. So without wasting time, let's dive right in. I started with writing a brief introduction about this project. I said a sleep disorder is a medical condition that affects an individual's ability to have a healthy and restorative night's sleep. Sleep is an essential part of our daily routine, and disturbances in this natural process can have profound impact on physical, mental, and emotional well-being. There are various types of sleep disorders, each characterized by distinct symptoms and underlying causes. Understanding and addressing sleep disorders are crucial for overall health and quality of life, as untreated conditions can lead to severe health consequences. Machine learning and AI algorithms are also used to predict which patterns are at the highest risk of sleep disorder and enable healthcare providers to intervene proactively to prevent sleep disorder. So these are the objectives for this project. An health insurance company has tasked us to identify whether or not a potential client is likely to have a sleep disorder. The company wants to use this information to determine the premium they want the client to pay. Our goal is to construct a classifier to predict the presence of a sleep disorder based on the other factors in the data set. To achieve this objective, we have to prepare a report covering the following. 1. Analyze the distribution of sleep duration or quality of sleep for each occupation. 2. Explore if an increased physical activity level results in a better quality of sleep. 3. Explore if the presence of a sleep disorder affects the subjective sleep quality metric. 4. Analyze the link between age and sleep duration. 5. Analyze the factors that could contribute to a sleep disorder. So the next thing I wrote about is about our data and methods. So this is our data. Our data set is coming as a CSV file. Our data set is a synthetic data set that contains sleep and cardiovascular metrics as well as lifestyle factors of close to 400 fictive persons. I'll go ahead and import our libraries and the data set which we'll be using. So to import the libraries, would import Pandas as PD, NumPy as MP, Matplotlib.pyplot as PLT, and Seaborn as SNS. Those are the few libraries we'll be importing for now. The next thing I did was to go ahead and read in our data set, and we use the pd.read_csv method, saving our data set as sleepdf. I went ahead to use the dotted method to look at the first 5 rows of our data set. Next, we have to use the .info method on our data set to gather some brief information. So using this .info method, we can view our data set and see we have 374 rows of data with 13 columns, and in all our columns of data we don't have any missing values. We can also see the data types of each of these columns. Now let's go ahead for data cleaning. You know, data cleaning is very important when it comes to analyzing your data, as it might affect your insights or information gotten from your data if your data set is not well cleaned. For the data cleaning, the first thing we did was to look at the sleep disorder column and we replaced the none values with no disorder. So if I scroll a bit up, we would see that we had some values that were none, and these values represented patients that did not have any sleep disorder. I changed those values to no disorder. The next thing I did was to look at the blood pressure column and split that blood pressure column into systolic and diastolic values using the stro.split method. So also, if I scroll up and we take a look at the blood pressure column, you see we have these values: 128/83, 125/80, and so on. So these are the systolic values over the diastolic values. I splitted this column into two separate columns for easy analysis of our blood pressure values. Another data cleaning I did was on the BMI category column. I also made use of the stro.replace method to replace normal with normal weights. And you could see, after I checked the unique values of this BMI category using the .unique method, we could get our three unique values: overweight, normal weight, and obese. The next thing we did was to view the unique values in each data columns, and I used the .unique method to do that. So it was easy using a for loop. You can see we have the gender, male and female, we have the various age, occupation, sleep duration, quality of sleep, physical activity column, BMI category, blood pressure. So you could see these are how blood pressure columns looks like before: 126/83. Okay, our heart rates. But now you can now see that we added two columns, systolic and diastolic, and these are systolic column containing only our systolic values, and our diastolic column containing only our diastolic values. So next, I needed to categorize our age column into category. I wanted to have a situation where we have younger adults, middle-aged adults, older adults, and elderlies. So for me to be able to do that, I had to use the .describe method first of all to describe the age column, so that I could see what is the lowest value, what is the highest value, or the maximum value. So using the .describe method, it was easy for me to go ahead to do that. Then I use those values to create bins for the various age categories which I want to create. From 0 to the 25th quantile will be for our young adults, while from the 25th quantile to the median value will be our middle age. Median value to the 75th quantile will be our older adult, while from the 75th quantile to the maximum value will be our elderly. So you could see I created the labels, I created our bins, and I used the pd.cut method to create our category. So it's very easy and straight to the point. So when I was done with that, I wanted to visualize the categories which I have created. So let me go ahead and click on this so that I can get a full view of this visualization. So you could see we had more middle-aged patients, followed by our young adults, older adults, and elderlies. I also check for duplicate values in our data set using the duplicated method and the .sum method, and you could see we did not have any duplicates in my data set. So that was all we did for cleaning this data set. The next thing I went ahead to do was to conduct an exploratory data analysis. I went ahead to view the first 5 rows of this data once more so that I don't have to scroll up whenever I needed more information. I used the .describe method also on this data set to get some numerical analysis about our data set. So from this, you could see for our numerical column age, sleep duration, quality of sleep, physical activity level, etc. From here, you can see their mean values, the minimum values, the 25% quantile value, the median, the maximum values for each of these numerical column. So using the .describe method always comes in very handy when analyzing your data. Also, for your categorical column, you can also use the .describe method to analyze your categorical column, but this time around I added the exclude parameter, stating that I wanted to exclude the numerical columns because I've already analyzed the numerical column already. So I just want to look at our categorical column. So you can also use the .describe method, but you have to pass in this parameter stating you want to exclude numbers. For our gender, you could see we have two unique genders, male and female, and we have more male than females. We have 11 different occupations with nurse coming top. Our BMI category, we have 3 different BMI category with normal as the most frequent. You could see the most frequent blood pressure value, our age category, and so on. The next thing I did was to get only the numerical columns in my dataset using this .select underscore dtypes method, and you could see that I've added this exclude parameter to exclude object and category data types. And why did I do that? I wanted to analyze our numerical values. Previously we used the .describe method on our numerical columns to get some statistical analysis, but this time around I want to see some other analysis which I can get through visualizations. I created a distribution graph. With this distribution graph, we can see how our numerical data are distributed, if we have a normal distribution shape or not. So to do this was very easy. I used the plt.subplot method in Matplotlib. With this you can create different visualizations for your columns of data, and I also implemented using a for loop to loop through these various columns. So I created a KD plot for these various columns. Let me go ahead and click on this so that I can get a full view of our graph. So you can see the distribution of the age column, sleep duration, quality of sleep, physical activities, and you can see that most of these columns are not fully normally distributed, although they have this bell curve shape. You can see some changes or discrepancies in their shape. I also used a box plot for these various columns to look at their distribution. I wanted to see some columns that had outliers because box plot can help us in doing that. So using the box plot, let me go ahead and click on this. I was able to find out that our heart rate column had a lot of outliers. So you can see this dot representing outliers for this column. You can see for other columns there were no outliers. Now I went further to investigate this heart rate column and to look at how many rows in this column had outliers. To inspect the outliers, I used the IQ arrow equals to our 75% quantile minus our 25% quantile. Setting the lower band and the upper band, I was able to subset for those rows that had these outliers and use the count method to count the number of those rows that had outliers. So at the end, I discovered that we had a total number of 15 rows with outliers. So the next thing I did was to get only our categorical columns, which is the age category, sleep disorder, BMI category, occupation agenda. And you can see that I also applied the drop method to drop the blood pressure, because if you can remember, we've already created 2 columns from our blood pressure, right, which is the systolic and the diastolic column. So this blood pressure column is no longer necessary for our analysis. After this, I went ahead to create a visualization to visualize the distribution of our categorical columns. I use the Seaborn count bot to create this visualization. So if I go ahead and click on this, you will see we have our gender where we have male and female, our various occupation, and you will see nurse as the most highest, followed by doctors, engineers, and lawyers. Then we have our BMI category with normal coming the most occurred. We have our sleep disorder and age category with middle age as the most occurring age category. So now we can go ahead and start tackling our various objectives. The first objective we'll be answering is what is the distribution of sleep duration for each occupation. So I went ahead to use the group by method to get the sleep duration summary statistics. So I group sleep duration by the various occupation, and I use the .describe method to get the summary statistics. So if we look at this, we could see our occupation where we have accountant, doctor, engineer, etc. in this column, where you can now go ahead to see the average sleep duration, their standard deviation, the minimum sleep duration, their 25% quantile, the median 75% quantile, and the maximum sleep duration for each of these occupations. And you can see from this table that the occupation with the highest average sleep duration is engineering, which is about 7.9. So let's go down and see if we can gather more analysis from this data set to answer this question. The next thing I did was to use a bus plot to visualize the distribution of sleep duration by occupation. I created a bus plot using Seaborn, and I ensured on my x-axis we have occupation, while on the y-axis we have sleep duration. If you go ahead and look at this visualization which we have here, we had some outliers for teachers, accountants, and engineering, and you can see that there are some occupations that we do not have enough data regarding them. For example, the manager, you could see we just have few data points for it. Sales representative, even our accountant also. So if I go down, this was my analysis which I wrote down. Analyzing the sleep duration across various occupations provided insight into how one's profession might influence sleep patterns and its potential connection to sleep disorders. These findings are valuable for insurance companies in identifying clients at risk of sleep disorders. Using bus plots, we can visualize key statistics including sleep duration at the 25th, the 50th, 75th, and the 100th percentiles for each occupation. In our analysis, accountants had a mean sleep duration of 7.11 hours with low variability. Doctors had an average sleep duration of 6.97 hours with slightly more variability, while for engineer we had an average sleep duration of 7.99 hours with a moderate variability. So you can see the various information we got for these various occupations. Also, I'll be dropping the GitHub link to this project so that you can go ahead and analyze this project on your own at your own convenience. With that being said, let's go to the next question, which is what is the distribution of quality of sleep for each occupation? Our first question will look at sleep duration for each occupation. Now we'll be looking at the quality of sleep for each occupation. So using the same method which we used earlier, we use the dot group by to get sleep quality summary statistics. So we use the dot describe method on quality of sleep, grouping by occupation. So these are our various occupations, and these are the statistics we got for the quality of sleep. So you can see the average value for accountants, that for doctors, engineering, etc. And if you go through this table, you'll find out that engineers had the highest average quality of sleep of about 8.4. And so next, we'll be using a bus plot to view the distribution of quality of sleep by occupation. I use the Seaborn bus plot to visualize our data using occupation on our x-axis and quality of sleep as our y variable. So if you look at this, you would also see that, just like we said earlier, teachers, sales representative, accountants, lawyers, salesperson, managers, they had few data points in regards to this data. If you go down, you also find a summary of what I analyzed from this data set. I said analyzing distribution of sleep quality across various occupations provide valuable insight into the impact of one choosing profession on their sleep patterns. Interpreting the information gained from this bus plot, we can draw several noteworthy conclusions. Engineers on average enjoy the highest sleep quality with an average duration of approximately 8.41 hours. This group exhibits minimal variability in sleep quality as indicated by their low standard deviation. Doctors maintain an average sleep quality of approximately 6.65 hours, showing a moderate level of variation. This suggests a somewhat more diverse sleep patterns within its occupation. Nurses exhibit a broader range of sleep quality with a mean duration around 7.37 hours. Notably, the standard deviation is approximately 1.55, highlighting a greater degree of variability in sleep quality within this group. Sales rep, although data for this occupation is limited, the available information suggests a mean sleep quality of 4 hours with no discernible variability. The next question we'll be answering is, does an increased physical activity level result in better quality of sleep? Since we want to look at the relationship between increased physical activity level and better quality of sleep, we used a scatter plot to show the relationship. So I used the Seaborn scatter plot to visualize this using the physical activity level as our x variable and quality of sleep on our y-axis. So if you look at this graph, you'll find out that as physical activity level increased, our quality of sleep increased also. So to be able to answer this question more better, I also created an hypothesis. So our null hypothesis states that there is no significant difference in the quality of sleep between these two groups, and these two groups I mean increased physical activity level and reduced physical activity level, while the alternative hypothesis states that there's a significant difference, that is increased physical activity leads to better sleep quality. So I also set this significance level to 0.05. So let's go ahead and see how I went about using hypothesis to answer this question. So first of all, I subsetted my data to get only the two columns we'll be looking at, which is quality of sleep and physical activity level. Since I wanted to split the physical activity level column into two groups, just want to analyze if increase in physical activity level will lead to better quality of sleep, right? So I needed two groups of data. I had to use the .unique method to look at the unique values of these columns. Then I also use the .describe method on this column so that I can get some analysis on how this column look like. I want to see the minimum value in this column, the maximum value, the 25% quantile, and all that. So with this, I was able to divide our values into two groups. Any values greater than or equals to 60 as our group A, and values lesser than or equals to 60 as our group B. If you take note, I use this theta function so get the opposite of our group A. Next, I went ahead to import stats from SciPy.stats, as I'll be using the stats t-test_ind method to perform an independent t-test analysis. So these are data sets. So we have our group A data and our quality of sleep column. I have our group B data and our quality of sleep column. So to perform an independent test, we use the t-test_ind method from the stats library. We put in our group A data, our group B data, and these are the two values we want to get, our t-stat and our p-value. So the next thing we do is to check if the p-value is less than the significance level, which we've set earlier on as 0.05 when we're creating our hypothesis. So we said if our p-value is lesser than our alpha, which is our significant value, we are going to reject the null hypothesis, meaning that there's a significant difference in sleep quality. While if our p-value is greater than our significant value, we are going to fail to reject the null hypothesis, meaning we are going to accept the null hypothesis, that is there's no significant difference in sleep quality. After running this our analysis, at the end of the day we rejected the null hypothesis, stating that there's a significant difference in sleep quality. This means that increase in physical activity level results in better quality of sleep, and it corroborates with the answer which we've gotten previously from our scatter plot. So let me go ahead and read the summary of the analysis. I said the scatter plot presented above reveals a positive correlation between an individual's physical activity level and the quality of sleep they receive. It's evident that as the level of physical activity increases, the quality of sleep also demonstrated an upward trend. To delve deeper into the relationship between these variables, a hypothesis test was conducted using the SciPy t-test_ind method. This test aimed to determine if a statistically significant difference exists in sleep quality between two distinct groups of data. Group A comprising clients with a physical activity level of 60 or higher, while Group B consisting of clients with a physical activity level below 60. Upon completing the hypothesis test, the result led to the rejection of the null hypothesis. This signifies that a statistically significant difference exists in sleep quality between the two categories of physical activities. In conclusion, increased physical activity appears to be linked to improved sleep quality. So we can now go ahead and look at our fourth question, which is, does the presence of a sleep disorder affect the subjective sleep quality metric? So in this question, what we're technically saying is, does sleep disorder affect the quality of sleep somebody gets? So we also use the group by method to analyze this question. We group by sleep disorder for our various quality of sleep and use the dot describe method to get the statistical analysis of this column. So you can see for our various sleep disorder, insomnia, non, and sleep apnea, the average sleep quality for insomnia is 6.5, while for those that do not have any sleep disorder is 7.6, while for those that have sleep apnea we have 7.2. So next, I want to use a bar plot to show the relationship between the two columns. So this bar plot is going to be showing us the average quality of sleep by sleep disorder. The first bar is showing us the average quality of sleep for those patients that do not have any sleep disorder, while the next is showing us the quality of sleep for those patients that have sleep apnea as a disorder, while this is showing us the average quality of sleep for those patients that have insomnia as a sleep disorder. And from this graph you can see that those patients that have had the highest average quality of sleep, followed by those with sleep apnea, then with those with insomnia. So next, I also went ahead to create an hypothesis testing. I created the null hypothesis stating that there is no significant difference in subjective sleep quality scores among these three groups, which is non, sleep apnea, and insomnia. And the alternative hypothesis was there's a significant difference. Our significant value was set at 0.05. So to carry out this hypothesis testing among these three groups, I'll be performing the ANOVA test, and to do that, first of all I have to import the Penguin library. So I use the ANOVA method from the Penguin library. I passed in my data set, which is the sleep DF, and the column which we'll be looking at, which is quality of sleep, and the categorical column, which is sleep disorder. So the next thing is to extract the p-value from your ANOVA results. So using the dot lock on your ANOVA results, you have to set your p-value variable. Next, I check if the p-value is less than our choosing significance level, which is 0.05. If the p-value is less than our significance value, this code is going to print that there is a statistically significant difference in subjective sleep quality among the groups. Else, it prints there is no statistically significant difference in subjective sleep quality among the groups. After running the code, we got that there's a statistically significant difference in subjective sleep quality among the groups, and you can see that from our visualization earlier on, because you can see that those that did not have sleep disorder had higher sleep quality than those that had sleep disorders. So let's go ahead and read the summary of our analysis. The analysis of both the table and the bar graph offers valuable insight into the quality of sleep across different sleep disorder groups. Let's examine the key findings for each group. For our insomnia group, the average quality of sleep is approximately 6.53. Sleep quality within this group exhibits a moderate standard deviation of around 0.80, and the range of sleep quality varies from 4.0 to 9.0. Approximately 25% of individuals in this group experience sleep quality scores below 6.0, while the remaining 75% report values up to 7.0. While for the no disorder group, that is people that do not have any sleep disorder, the no disorder group is the most extensive, comprising a significant number of records. The average sleep quality for this group is approximately 7.63, which is slightly higher than the insomnia group. Sleep quality within this group spans from 6.0 to 9.0. The median sleep quality score is 8.0, implying that 50% of individuals in this group report sleep quality at or above this value, while the next category was the sleep apnea group, and we said this group exhibits an average sleep quality of about 7.21. Sleep quality within this group is characterized by a relatively higher standard deviation of approximately 1.65. The range of sleep quality in this group extends from 4.0 to 9.0, and about 25% of individuals in this group experience sleep quality scores lower than 6.0. In summary, this data offers valuable insight into sleep quality among various groups with distinct sleep disorders. The no disorder groups tend to have the highest average sleep quality, while the insomnia group, although slightly lower on average, shows less variability. On the other hand, the sleep apnea group exhibits the highest variability in sleep quality scores, encompassing a wide range. To further explore the relationship between these variables, an analysis of variance, which is an ANOVA test, was conducted using sleep quality as the dependent variable. The results indicate a statistically significant difference in subjective sleep quality among the groups, highlighting the importance of sleep disorders in shaping individual sleep experience. So the next question I answered is, what's the link between age and sleep duration? So to answer this question, I made use of the describe method. I grouped our sleep duration column by our various age category, which is young adults, middle age, older adults, and elderlies. And from this table, we could see that the elderlies had an higher sleep duration hours of about 8.0, followed by the middle age, which was about 7.2, then the young adults and older adults. We could also get other analysis like the standard deviation and how these values varies among themselves, the minimum value, the maximum value, the median, 25% and the 75% quantile. Next, I use a scatter plot to look at the relationship between age and sleep duration, and I use the Seaborn scatter plot method to go about creating this visualization. So if you look at this graph, if you take note, I did not make use of the age category column which I created. I used the original age column which came with this data set. That was how I was able to create this scatter plot, and using our sleep duration. From this visualization, you will see that the higher the age value, higher the sleep duration value. So next, I'll go ahead and read the report which I gave. I said the data presented in the table summarize the quality of sleep scores across the different age categories. So you can go ahead and read this at your own convenience. Like I said earlier, I'll be dropping the GitHub link to this project or to this notebook so that you can go over it. I will just be reading the summary alone. In summary, the data provides insight into the quality of sleep across different age category. Middle-aged adults have the highest average sleep quality with relatively low variability. On the other hand, elderlies report the highest average sleep quality with slightly more variability. Young adults and older adults fall in between, with their sleep quality average and variability falling within those of the other groups. These statistics can be valuable for understanding sleep patterns and quality of sleep among individuals of varying age groups. So next, we'll be looking at what factors can contribute to a sleep disorder. So to answer this question, I use the sns.itsmap method. I passed in our data, which is numeric_core.matrix. And how did I get this data set? First of all, I subsetted for only the numeric core columns using the select_d types, and I stated that it should include only numbers. Then when I was done with that, I used the .com method to get the correlation values of these columns. Then I saved this as a data set. So it was this data set I passed in our sns.itsmap method. I set not to be true, and I determined the color of this our map using the CMap parameter. Now let's go ahead and look at this its map. So these are sleep disorder column. Now we'll go ahead and look for those columns that have high correlation with our sleep disorder. You can see our diastolic and our systolic value has about 0.7 and 0.78 each. So these two columns are highly correlated with sleep disorder. We also have heart rate column also. Age is another column that is correlated with sleep disorder. So next, I also wanted to look at the correlationship between the categorical column and sleep disorder. You know, these are first heat map was just for our numerical columns with sleep disorder. So to do that, I had to import chi-square contingency from SciPy.stats. I got our categorical data only using the .select underscore dtypes method and setting our parameter to exclude all numeric columns. Next, I had to create a chi-square matrix. To do that, I use the pd.data frame and I pass in the columns of this data as our index and columns parameter. So I went ahead to create a for loop to go through the data set and create a chi-squared matrix. Then to visualize this chi-square matrix, I use this sns.heatmap. So if we go ahead and look at our heatmap which we created for this categorical data set, you can see that there are two columns that are highly correlated with the sleep disorder column is the blood pressure column and the occupation column. So for the summary, I wrote that heat map above shows occupation, blood pressure, age and heart rate as top factors that contribute to sleep disorder. So with this, we've answered all our objective questions. So I went ahead to carry out some further analysis analyzing the sleep disorder columns. So for this, I carried out some findings on sleep disorders and the age categories. So I decided to rank sleep disorder by age group. Which of this age group had more sleep disorders? So to do that, I used the dot group by method, used the dot size method and the dot reset underscore index method. I also use the pandas dot pivot underscore table to pivot our age group, setting the index as sleep disorder, columns as age category and our values as count. If you look at this pivot table, you see we have our sleep disorder, insomnia, none and sleep apnea. And looking at our rank of value, you will see for insomnia, older adults came as number 1. They had the highest ranking, while middle age ranked number 2, with young adults and elderlies ranking 3rd position. While for those that does not have any sleep disorder, we have young adults, middle age and elderlies coming top. Also for sleep apnea, we have the younger adult, older adult and elderlies ranking number 2, with middle age ranking number 3. So to make this more colorful, I decided to create a function to color our ranks. So this was the outcome. So this is the code written here on how I went about creating this table. So aside from that, I also went ahead to create a bar plot to show the distribution of sleep disorders by the various age group. Using the Seaborn can plot, I was able to create this graph, and from this you see we have the young adults and the count of sleep disorders by their age group. So let's go ahead and look at the various coloration. The darker blue is for those that don't have any sleep disorder, lighter blue is for sleep apnea, and this light blue color is for insomnia. Now if we go ahead and look at this visualization once more, you will see the distribution of these various sleep disorders among our various age categories. You see for middle age, we had more people that does not have any sleep disorder. We have fewer people with insomnia and just few people with sleep apnea. While for older adults, we had more people with insomnia, few people with sleep apnea and fewer people with no sleep disorder. For elderlies, we had fewer people with no sleep disorder, few people with sleep apnea and the least amount of people had insomnia. So let's go ahead and scroll down. The next thing we looked at was exploratory data analysis on sleep disorders and categorical column. To do this, I created a table analysis for each categorical column and sleep disorder, and this is the code I use in going about this analysis. I grouped sleep disorder by the various categories. For example, this was gender. I did a value count, are normalized to be true to be able to get their percentage values. I also ran these figures and used the reset_index method. I did this for the various categories, and these are the tables which we got. So this was for gender and sleep disorder. So for female, you can see that 44% did not have any sleep disorder, while 36% had sleep apnea, 90% had insomnia, while for male, 72% did not have any sleep disorder, 22% had insomnia, and 6% had sleep apnea. So you can go through these tables to see the various percentage of sleep disorders for the various occupations, the various BMI category, blood pressure values, daily steps, etc. So you can see for each table we had a particular category we analyzed with sleep disorder. So aside from that, I also carried out a visualization analysis also. So I created a cat plot using Seaborn, and to make it easier, I created a user defined function called the plot_bar_graph. So to do this was very easy. All I had to do was to loop through each columns in our categorical column. So you can see with this, I was able to get all the columns I wanted to work with, right? So all I had to do was to loop through each of those columns in our created columns here. Then I used the Seaborn cat plot to go ahead and create my visualization. So this is a cat plot, and if I click on this, we will get a few visualization of what this plot is about. You could see here that it's a count plot. We set the kind to count various male and female values for each of these sleep disorders. So for none, you see we have more males. For sleep apnea, we have more females. For insomnia, we had more males. So this is just a visualization of our table which we've seen earlier. So with this graph, you can get more analysis at first sight if you don't want to go through the long process of looking at the table and trying to get a visualization one after the other. So let me just go ahead and minimize this. The next graph I created is a pair plot, and with this pair plot I can see the relationship and also visualize the distribution between our columns of data. This is the code I wrote to be able to create this pair plot. If you can see here, I set the kind of this plot to KDE plot. So if I go ahead and click on this, let's get a better view of what this visualization looks like. Here you can see the various colors we use in representing the various variables in our sleep disorder. So if you look at this first one, we'll first see the shape of distribution for the various variables of sleep disorder for this sleep duration. Then it then shows us a scatter plot showing us the relationship between sleep duration and quality of sleep for the various sleep disorder categories. Sometimes it's a bit difficult to get information from a pair plot because we have a whole lot of insights we are looking at a glance. So it's difficult for you to focus on a particular visual to get your findings. So with that, I'll be ending this video at this point. So this is all about the exploratory data analysis on this data set. Okay, in our next video we'll be looking at how I went about to pre-process this data for our machine learning and the various models we use to carry out our machine learning. So endeavor to like and subscribe to my YouTube channel for more content relating to healthcare data analysis. Also share this video to your friends, family and loved ones that are interested in analyzing healthcare data. Turn on the notification bell so that you'll be the first to get notified whenever I drop a video. And most importantly, drop your questions and comments in the comment section as I'll be going through and ensure I reply each and every one of you. Bye for now and see you in our next video.